Welcome to my solar system Google Earth project. I'm going to orient you first. On the left is all the information concerning the sun, their planets, and kind of the orbits, sort of. Um, Most of my information came from nasa.gov, the planetary fact sheet, where essentially defined to model the planet size, I took the diameter in kilometers. Well, actually, I should talk about this too. The distance to the sun for each planet was recorded in kilometers times 10 to the 6. And this number comes from averaging the perihelion and aphelion of each planet. You just add them up, divided by 2. Perihelion being closest to the sun, aphelion being furthest away. So in Google Earth, I'm using circles, and I understand that the orbits are not perfect circles given that perihelion and aphelion, but this is the best that I could do, and we can kind of thank Newton for this problem that I'm running into. Anyway, back here. Since the diameter is in kilometers and not kilometers to the 10 to the 6th, and since it's diameter and to draw a circle we use the radius, I did a spreadsheet here, and I plugged in the diameter, and then my formula simply just took the above cell and divided by 2 to find the radius. And then this formula divides that radius by 10 to the 6 to shrink it down to that scientific notation. And the one thing that was absent was the sun. So, oops. I went here, found the radius of the sun, and then applied the same calculation, dividing 10 to the 6. And notably, the sun is gigantic and Pluto is absolutely small. And that was apparent in here. Here are all their orbits, like I said again, and they're all color coordinated. And let's start with the sun at the center of the solar system. And I did it at the Hayden Planetarium, so I'm going to zoom in there. And this will be the largest circle representing our star. So there's the sun, and zooming into the planetarium, you can kind of see it there. And I'm just going to do this for each planet. The planets are in white for the most part, just to give it some sort of sense. And in this bar to the left, you can see those calculations. Now, these planets are so small, the first 4, Mercury, Venus, Earth, Mars, are super small compared to the others. So it's really hard to see their circles. You got to zoom in super close. So they are there, but that's why they are so difficult to see. So we're going to move on to Venus. And you can kind of see that white circle there, but we'll zoom in a little bit so you can kind of see it. Like I said, I'm just using that calculation, and we'll go to the Earth next. And I just mapped out these circles, and I tried to pick something that was like an interesting landmark that was somewhere on the path. And when we go to Mars, that's where we're going to see where we run into the first problem I encountered. I was trying to be cute at first, picking interesting locations, and I didn't realize when I'm over, desolate locations like a huge body of water or something like a desert, Google Earth doesn't really zoom properly. It zooms out further than it does with places with landmarks. So that's why that Mars marker is a little off. But I corrected and I scaled the planet appropriately. And it was graphing Mars that I realized I had made a mistake earlier graphing the other planets, because by the time I got to Jupiter, I noticed Mars and Jupiter were about the same size of a circle. I was like, oh man, I'm off decimal places. I'm off 1 decimal place on the others. So yeah, Jupiter truly dwarfs the first 4 planets. And I think this is Nova Scotia over here. Let's just jump to Saturn, another big planet. It's 0.06 kilometers times 10 to the 6, whereas the previous ones, excluding Jupiter, were 0.00. That I was 10 times off, and a little factor more. So let's just finish this up going to Uranus, which is, yeah, boom, right there. And then we've got 2 more left. And Neptune was kind of a fun one. And this is another one where I ran into scaling issues since it's in a chain of islands, but it's by the Galapagos. And Neptune's quite small. And then the last one was my favorite, was Pluto, because Pluto is, you know, furthest planet from the sun, therefore the coldest at, you know, average temperature of minus 225 Celsius, and here it is in the Sahara Desert, which is just irony if you think about it. Boom. Sahara Desert, Pluto. So that concludes my project on the solar system, and I'm just going to, you can pause the video here to see the calculations. Alrighty, thanks.